Just wait a second. So yesterday we ended that we will be talking about the electron displacement effects, right? Yes, Abhinav and Reba.
Yes, sir.
Electron displacement effect. How different groups and atoms that are attached to a particular intermediate, they are going to affect the charge density. Okay, so we are looking forward to maintain the charge density. So write the electronic displacement effect or electron displacement effect. Electron displacement effect. There are two types of electron displacement effect. One are the permanent effects that are already there. As soon as you have the molecule, the permanent effect. And then you have the temporary effect. Okay, permanent effects and temporary effects. So in permanent effects, we have inductive effect that we'll learn first. Secondly, we have the resonance, the phenomena of resonance, which gives us the mesomeric effect. Thirdly, we have the hyperconjugation. Now, in temporary effect, we have just one, that is the electromeric effect. That is the electromeric effect. So write these down. We will start with inductive effect. Yes, guys. Let me know if you're done, okay? Reba is done. Abhinav is done. What about Surat and Sara? You guys are writing? Sara, Surat. Yes. Hello, Sara. Are you done or are you writing? Done. What about you, Surat? Can you please raise your hand if you're done, Sara? What about you, Surat? Thank you, Sara. Okay, Surat is also done. Thank you. Right, inductive effect. Inductive effect. Now, what is inductive effect and what is the driving force for inductive effect? It is the simple, good old electronegativity. So please write. The driving force is what? It happens due to the driving forces. Force is electronegativity difference. Okay, now what is inductive effect? Please write that. Please write what is inductive effect. The partial shifting of sigma electrons, partial shifting of sigma electrons towards more electronegative element or group. Okay, towards more electronegative element or group. Right, next there are two types of inductive effect. The number one is the plus I effect. Okay, plus I effect. So what is plus I effect? When a less electronegative element or group, when a less electronegative element or a group is attached to carbon chain, then it tends to donate electrons through inductive effect. So for example, you have a carbon. So this is a carbon chain, and here you have an element which is, let us say that it is A. Okay, it is A. Now I am saying that A is less electronegativity. The electronegativity of A, it is less than the electronegativity of carbon. And what is going to happen in this carbon and A bond? This carbon and A bond, there are two electrons which have been shared, but the sharing will be more towards carbon. That means the electron will be given to some carbon atom, right? Then it will get a delta negative charge. Now, as you know, that if this is delta negative, then it is going to give some more electrons here. Then it is also going to get some electrons. So delta negative, delta negative. Okay, that means this A atom, it is giving electrons through sigma bond, partial shifting of electrons through sigma bond towards C. And this is the plus I effect. And this is when we have a less electronegative atom which is attached to carbon chain. And for example, you can have Mg, which is a metal. Mg is a metal and it has electropositive character. That is why it can give electrons. Okay, it can give electrons. So we'll write the different plus I groups. We will write the different plus I group as of now. Let's keep it till here. Then we will write the minus I effect. Right, the second part, minus I effect. Now the same thing, but when a more electronegative element or group element or group is attached to the carbon chain, then it tends to withdraw electron through inductive effect. Now in this case, you will have carbon, a carbon chain like this, let us say, and it is bonded to an atom X. Now I will say the electronegativity. Okay, X is not a good example because the electronegativity also has the same sign. So rather, let us take Y and let us say that the electronegativity of Y, it is greater than the electronegativity of X. And what is going to happen here? The Y, it is going to pull electrons from the carbon chain. It's going to pull electrons from the carbon chain, right? This. So this Y will get a delta negative charge. The carbon will be getting a delta positive charge. This will be getting a delta positive charge, and so on. The effect will be slowly decreasing as we increase the number of carbon chain. So the highest magnitude of effect will be seen in this carbon atom, which is directly attached to the more electronegative element in the minus I effect. Okay. So you can write an example here, but we'll be looking at more while writing the groups. For example, you can write a carbon which is attached to, let us say, a bromine group, right? So bromine is more electronegative, it will be pulling electrons from this carbon atom, okay, from the whole chain. So write this down, let me know if you're done. Then we'll write the plus I groups and minus I groups. Okay, Reba is done. Please raise your hand if you're done. Okay, only Reba is done. What about Abhinav, Najib, Umar, Sara, and Surat? Guys, please raise your hand if you're done. Waiting for Sara and Surat. Okay, Sara is done. Okay, thank you. So right next, so the groups, let us first of all write. This is more important, okay? The plus I group. Plus I groups. Okay, wait a second. Let us first of all write minus I groups. They will have more applications. Minus I groups and its application. Okay, minus I group and its application. Okay. Now, the order, first of all, we should write the order of minus I groups. Okay, the order of minus I group. So please start writing. So the highest minus I effect will be shown by a group which has a nitrogen and it has 3 fluorines attached to it. The nitrogen, it has 3 fluorines attached to it. Now, obviously, when this has nitrogen has 4 bonds, it will be getting a positive charge. Okay, so if the carbon atom is attached with this group, then that means it is the most electron withdrawing group. Okay, minus I means electron withdrawing group, as we have written earlier. Now, this is the most electron withdrawing group. The next would be, okay, now if I add one hydrogen, then it will be less than that. If I add another hydrogen, it will be less than that. If I add another hydrogen, it will be less than that. But let's not worry about that. You'll not be seeing this group much, but still just write this in case. Okay, in case. This is the second. This will be followed by if you have NH3 that is attached, and you will obviously have NH3 positive because this nitrogen is attached to a carbon atom and also 3 hydrogens. Now, again, 4 bonds, that means this nitrogen will be having a positive charge. Please remember that we are not just looking at the electronegative elements, we are rather looking at the groups. So the groups, electronegative of groups, they depend on some different factors, as we will conclude at the end. Okay, the next is NO2 group. If the NO2 group is attached, This is something that you will often see, NO2 group attached. Okay. Then what next is the CN group, right? So CN group, if it is attached, this is also something common that you are going to see more often. Then we will see that you will have carbon, double bond O, and a hydrogen. That means which is group? Aldehydic group, aldehydic group. Followed that is the ketonic group, where you have C, which is double bonded to oxygen, and it is singly bonded to some R group, right? Some R group. Followed by the carboxylic acid group, which is C, doubly bonded with oxygen, single bonded with OH. Now, these are the groups that you are going to see more often. Now, here we are followed by a series of halogens. That is, we will have fluorine, followed by chlorine, by bromine, and then iodine, and then iodine. Next up is the OR group. Now, this oxygen is having some lone pair electrons, right? Okay, and followed by the OH group. Again, this oxygen is going to have some lone pair electrons. Then we have the alkynes. That means you will have, if a C triple bond CH, it is attached to a carbon chain. Now, this carbon is also having some electronegative minus I effect, and its electronegativity is higher than the normal sp3 carbon. Okay, normal sp3 carbon. We will look at that Y, then followed by NH2. Okay, now this is followed by the benzene ring. The benzene ring, which is followed by a carbon doubly bonded with the carbon CH2, and at last we have the hydrogen. Okay, so these are all the groups which are more electronegative than hydrogen, and that is why these are minus I groups. These are minus I group. Now, there are some things common that I think we should consider here. Let us write what are the properties. So first of all, we saw that the things that affect the electronegativity of a group or an element is that the charge. If you have a positive charge, then obviously you are going to attract more electron towards yourself. So charge is the number one factor. If you have anything which is charged, it is going to attract more electron if you compare that with any neutral atom. Okay, so if you have anything which is charged, that is going to attract more electrons than any neutral atom, no matter however electronegative that is. If I am going to compare CH3 positive and I am going to compare oxygen, then obviously CH3 positive is going to be more electronegative because it has a complete positive charge. It can attract more electron. Oxygen is just an electronegative element. It has no charges. Okay, it has a tendency, but the nature of positive charge is what? It is to attract electron. It's going to attract electron. Okay, so whenever you have charge, so first thing is that is why what you are seeing here is that all the charged atoms, these are more electronegative. Okay, followed by, let us see NO2. So NO2, you can see a combination of what? You can see a combination of nitrogen and oxygen, two of the most electronegative elements in the complete periodic table. So if you have a group which has more electronegative elements, then it has more minus I effect. Now, also looking at the structure, so nitrogen double bond with oxygen and a single bond with oxygen like this. So NO2 is something like this. Now, if you see here, the number of bond nitrogen is having, it is 3 domains, right? It has 3 electron domains. That means the steric number is 3. A sigma bond plus lone pair. So there is no lone pair because it has 4 bonds. And that is why you can say the steric number is what? 3. And hence the hybridization for this is what? Hybridization is going to be sp2. Now, obviously sp2 is going to be more electronegative because it has more s character. So next thing is that the electronegativity is also going to affect. Okay, now here we have Cn. Now Cn is very much electronegative. Why? Because of its sp character, sp hybridization, and furthermore it is attached to a nitrogen atom which is more electronegative. So the overall effect is that it is going to be very minus I. It is going to be electron withdrawing group. Now this carbon atom, it has the hybridization, that is sp, and further it is attached to an oxygen atom. That is why it is going to be more electronegative. Now this carbon atom, it is attached to oxygen atom as the aldehydic group. This is also, sorry, this is not sp, this is sp2. This is also sp2. But in this case, this carbon atom is attached to an R group. Now this R group has some tendency. So what this carbon can do, it can attract electron from here also, and that is why it cannot attract in the same way from here. Okay, so it is equally distributed. That is why it is less than aldehyde. Okay, next is the carboxylic acid group. Now you can say that it has two oxygens attached to it, but one thing you should remember is that this oxygen is having lone pair electrons. Now this lone pair electrons can donate through pi bond that we will see in resonance. Okay, that we will see in resonance. That is why this is less electronegative than the ketonic group. Then we have our periodic table elements of halogens, which are ought to be electronegative elements, followed by the OR, OH, and so on. Now again, this C is very electronegative due to the sp hybridized carbon atom, but it is less electronegative than Cn, which is also sp, because the Cn has a nitrogen atom attached to it. Here we have NH2 because nitrogen is more electronegative. Then in benzene, we have this carbon atom. This carbon atom is sp2 hybridized. This again, carbon atom is what? It is sp2 hybridized. Now, why is the benzene more electronegative than this alkene here? Because this sp2 is attached with more and more sp2 hybridized carbon atoms. Okay, so please write this minus I groups. Then we will talk about the application. Write this down. Let me know if you're done. One application that you can all write up front is that the minus I groups withdraw electron and has the tendency to stabilize anionic species, right? It has the tendency to stabilize anionic species. Anionic species will have negative charges, and these minus I group, they will delocalize they will spread the negative charge over all the complete compound. That is why the charge density has been decreased. Next thing that we can write is minus I groups will destabilize the cationic species. Now, since cations, they are already electron deficient, what is going to happen if the minus I groups, they are attracting electrons, then the cationic species will get more and more electron deficient. That means the positive charge will increase. If the positive charge is increasing, the charge is bad for stability. If charge increases, the stability decreases. But in the case of anionic species, it is taking up the negative charge, right? It is withdrawing the electrons which has negative charge. That is why the anionic species, they get stabilized because the charge density has been decreased. Write this down, then we'll do some questions. Please raise your hand if you're done. Okay, waiting for Muhammad Umar, Reba, and Surat and Abhinav. Waiting for Abhinav and Muhammad Umar. Abhinav, are you not there? Let me know if you are not done. Okay. Compare the stability of following. Yes. So what we can do here, first of all, what you need to do, you need to see the charge. Okay, you need to see the charge. So the charge is what? The charge is a negative charge, right? So to stabilize a negative charge, you need to spread out the negative charge, right? You need something that should pull up the negative charge. It should be what? Something which withdraws negative charge. Now, how can someone withdraw a negative charge? They should withdraw electrons. That means you're looking at the electron withdrawing groups. That is the minus I groups, right? The minus I groups. Now, if I compare here, then A, it has none of the minus I groups. That means hydrogen. B has one minus I group. C has two minus I groups, and D has three minus I groups, right? So we can say that A is the least stable, followed by B, followed by C, and then followed by D. Okay. Since stability of anion is directly proportional to the presence of minus I group. Okay. So in this question, we have compared same groups that has been, we are increasing that group. Okay. We are increasing that group. Please write this down. Done, guys? Write this down. Let me know if you're done.
Done, sir.
Okay. Right, next question. Again, you have to compare stability, okay? Again, you have to compare stability. And a question you write. Okay. Now, in this case, again, what charge do we have? Can somebody answer me? We have a negative charge. We have an anion or a cation. We have what charge? An ion or a cation? Tell me. Charge is negative or positive?
Negative.
Negative. Very good. So what we need to do? We need to withdraw electron, or we need to give electrons?
Withdraw.
Withdraw electrons, right? To lower the charge, what we need to do? We need to withdraw electrons. Withdraw. Now it means that we need to have the presence of what? Minus I groups. Correct?
Yes, sir.
Minus I group. Now what we can see that all of these elements, all of these molecules, they have a minus I group, right? They have minus I group. Now what we need to compare is the power, right? The power of minus I, no? Which is having a highest strength of minus I, and which is less powerful minus I group, which is having like the higher capacity to withdraw electron, which has the lower capacity to withdraw electrons. So in this case, what we are going to do, we're going to use this particular, order. So in this, we can see that fluorine is most electronegative. That means what is going to happen now, if I write the order of the power of electronegative, power of minus I, then I can say that fluorine is the most, followed by chlorine, followed by bromine, and followed by iodine. And that is why I can say for stability, I can say that A is most stable, followed by B, then C, and then D. Okay. So we have seen two things. First of all, the presence of minus I group, it is going to stabilize a particular anion. Next is that we also have to look at the power of minus I, how strong the minus I group is. If we have a stronger minus I group, then it is going to stabilize the anion, stabilize the negatively charged species more effectively, right? Now we will look at some other cases, what affects the minus I. Now all of these are in applications. We are looking at stability. We will keep looking at these molecules, okay? Write this down. Let me know if you're done. Write this down. Let me know if you're done. You guys done? Okay, you have already raised your hand. Okay. Next is again compare stability. Okay. Compare stability. Now in this case, what I am going to give you, number A, we have, let us say, you're just taking the fluorine and CH2, COO negative, right? COO negative. Wait a second. Let me do something else. Not like this. 1, 2, 3, 4. 1, 2, 3, 4, 5. So 1, 2, 3, 4. Yeah. So we have a COO negative here. We have a fluorine atom attached here. And B is COO negative. The fluorine atom is attached here. C is, if you have the same molecule, COO negative, but the fluorine atom is attached here. And let me just crunch some space. And you have the fluorine atom attached here. These questions will not be there in NCERT. NCERT has just touched upon this area. Okay, so you'll find this in inductive effect. Inductive effect. Okay, so when I am going to compare the stability, again I have to look at the charge. If the charge is what? It is negative. Then I have to look that I have to give it some electron withdraw. I have to withdraw electron. Now I have to see the presence of minus I group. I can see the minus I group is there. Now I have to look at the power of minus I. That means which minus I group is present. Now, inductive effect, what I am seeing, Muhammad Umar, inductive effect minus I group. Okay. Now the power of minus I, if I will say that, then all of these are what? Fluorines. All of these are fluorines. Then I have to compare how? I have to look at the distance. I have to look at the distance. I have to look at the distance. Now I can say that if fluorine is it is attached to a carbon atom which is nearer to the negative charge, then it can attract electrons more easily and more effectively rather than when it is far away. So if I talk about the distance, then I would say that, sorry, I should write it like this. The minus I effect is inversely proportional to the distance. That means if distance increases, the effect of minus I, it has to decrease. It has to decrease because it is completely dependent on electronegativity. Okay, so this is one of the rules that you can write. And that is why if I talk about distance, then in distance, we will say that A is the nearest, followed by B, followed by C, and then followed by D. And that is why the stability, I will say, will be inversely proportional, right? It will be inversely proportional, and hence I can say that A, the most stable, followed by B, followed by C, and followed by D. Write this down. Let me know if you're done. Done, guys? Done? Yes or no?
Answer.
Fine. Now, let us look at these examples. Okay, let us look at these examples. So we had CS fluorine, CH2. Let me just write COO negative. Can you please turn the mic on and speak, Muhammad Umar?
Sir, on which day did you last conduct?
Yesterday.
Yesterday?
Yesterday, yeah.
Yesterday I was not there. I didn't receive any link.
We need to talk to Nishkar sir about that now. We always have a Saturday, Sunday. Same link. We have been having the same link for Saturday, Sunday for a very long time. Hai na? Does the link change for Saturday, Sunday, Muhammad Umar?
No, sir.
No?
No, I usually receive link
No,
for
that is you always have. I mean, you always get to know now if there is a cancellation. Yes or no? And I rarely cancel classes. No? So you will always get to know. Okay. Now it is your responsibility to ask if there is a class today or not. If you don't get the link, okay. Concentrate here. Don't think about yesterday. You can get the recording. Concentrate here. Now, when I have these molecules, right? When I have these molecules, I can trace that. I can trace these molecules, and I can say that these must be carboxylic acids, right? These must be carboxylic acids, and I can trace that. We would have something like fluorine, which is attached to CH2 and COOH. And this hydrogen atom would have been abstracted by some solvent or some base, and it would have been like this, right? So this type of reaction could have happened here. This type of reaction could have happened, that the acid that we have in here, that is a carboxylic acid, it would have given up its proton. Okay, so let me just fluorine, chlorine, bromine, and iodine. Okay, so all of you agree with this? Yes or no? Tell me. This could have happened. This is one of the potential reaction that can happen, which would have led us to the anion that we saw
Yes,
in the previous question. Yes? Okay, fine. Now, when we are talking about these reactions, let me just label them 1, 2, or A, B, C, D. Okay. Now, we all know that if I talk about the stability, then I can say that this is most stable, followed by this chlorine, bromine, and iodine derivatives. Yes or no? So can we say something about the rate of these reactions? Which reaction would have been faster and which would have been relatively slower? So we have the rate of reactions, right? Rate of reactions. So if I compare these reactions, then I can say that if the product is easily formulated, it is more stable, then the reaction can proceed in the forward direction more fastly. It can proceed in the forward direction more rapidly, right? So I can say the rate of reaction will be directly proportional to the stability of product, right? And in this case, our product is anion, and we have already looked at the stability of product, right? So in this particular case, I can write the rate of reaction is what? Because A is most reactive. That means the reaction that is happening in the A, which is faster, followed by B, followed by C, and followed by D. Yes or no? All of you agree with this?
Yes, sir.
Yes. Okay. Now one more thing. If A is happening more fast, and if A is the fastest, that means this A has the ability to protonate. It has the ability to release the H+ ion more easily, the most easily. Yes or no? Amongst the four, if A is giving this reaction very fastly, that means it is giving out H+ very easily. Yes or no? In this case, what do you think? Which is going to give H+ most easily? A reaction which is happening in a faster speed, or a reaction which is happening in a slower speed, which is going to give H+ more easily? In which case, the reaction which is happening in the fastest rate, the fastest speed, it is going to give out H+ more easily. Now the rate of reaction we have looked at. Now we can also comment on the acidic strength of the substrate here, right? Acidic strength. Now acidic strength, it depends on what again, it depends on the rate of reaction and hence the stability of product. So in this case, I can write the acidic strength of A is the highest, followed by B, followed by C, and followed by D, right? So we have come a long way from discussing the stability to the rate of reaction and then to the acidic strength. So please write this. Let me know if you're done. Let me know if you're done, guys.
Done, sir.
All of you done? All right, next. So we can say that. Let us summarize about minus I effect. Okay, let us summarize about minus I. Rather, let me first of all write the plus I effect, electron donating effect, and then we can summarize about the inductive effect as it is. Okay, inductive effect as it is. So please write plus I effect or plus I groups. Now the plus I groups are the electron donating groups. Okay, so they donate electrons through the inductive effect to the carbon chain. Now the electron rich groups, they will be only able to donate electrons. That means if you have somewhere negative charge, it is going to donate electrons. So the first one in this case is the CH2 negative, right? Followed by NH negative, followed by O negative. It is followed by COO negative. And if you have more carbon atoms, so it is going to give you more electron density. Okay, so this carbon atom, that is tertiary butyl, it is going to give you more electron density towards the carbon chain. Then followed by, if you have CH3, a hydrogen and a CH3, that is the 2-degree carbon. Followed by, if you have carbon, which is having only one CH3 group. Okay, and this will be followed by the CH3 group, only one. None of the this carbon atom is not attached to any other carbon atom. Okay, so this is 3 degree. A general trend that you should always remember for plus I group: 3 degree, 2 degree, and then 1 degree. Okay, 3 degree is the most electron donating group, followed by 2 degree, and then followed by 1 degree. I write this down. Let me know if you're done. Okay, seems you guys are done. So you can write some remarks. Write some remarks. Okay. So first of all, inductive effect. Inductive effect depends on the number of groups attached. That means we are talking about both plus I and minus I. If there is more plus I, that means more, if there are more plus I groups attached to a particular carbon chain, then there will be more donation of electron. If there is more number of minus I, then there will be more withdrawal of electron. Okay, so it depends on the number of groups attached. So the example would be the first example that we did. This carbon atom, it did not have any minus I. This had 1, this had 2, this had 3. So that is why the intensity of the withdrawal of electron, it will increase. Right, the intensity of the withdrawal of electron through inductive effect, it will increase. So it depends on the number of groups attached. Okay, number of groups attached. Second point is that it depends on the power of the group attached. Thirdly, it depends on, right, rather I should say it is inversely proportional to, it is inversely proportional to, it's inversely proportional to the distance. Okay, so if you have a minus I group or a plus I group that is very far apart, then the effect that it has to show, it will be lowered. The effect will be lowered as you increase the distance, Okay, so these are the 3 points that you should remember about inductive effect. Now let us write about the applications. So first is the application on the stabilities, right? Stability of intermediate. So first thing is the stability. So let me write the application. So in application, you can first of all write plus I groups stabilize. Plus I group stabilize. Plus I group, they stabilize what? Cations. Okay, that means plus will stabilize the plus groups. If you have cation, that means plus charge. So plus will stabilize plus Secondly, you can write minus I groups stabilize anions. Okay, they will stabilize anions. Thirdly, you can write the application on the acidic strength. Okay, so you can write acidic strength it is directly proportional to the minus I. So if you have more number of minus I group or the power of minus I, that means I'm generally writing the minus I effect. Okay, I'm writing the minus I effect. That means the acidic strength is directly proportional to the minus I group that are present in a particular substance. Okay, and I will also write that it is inversely proportional to the plus I groups. It is inversely proportional to the plus I groups, because as soon as you have COO negative and you are going to attach here, let us say CH2 negative, which is also a charged species, which is also a negatively charged, this is going to give it electrons. And when it is going to give it electron, the charge will increase. And if the charge is increasing, the stability will decrease. Okay. So these are the three main points that you should remember. The first two are more important if you talk about the 11th standard. Okay. Third one is more applicable in the reactions part that you will see in hydrocarbons and in the 12th standard. Okay, so write this down. Let me know if you're done. Done, guys? Okay. Just a small question. Look at your notes. Send the answer in chat.